So in continuation with the previous two lectures, so let us once again continue with the application of differentiation for extrema of functions. So friends, we know that in many field of science and engineering, we need to know what is the maxima and what is the minimum of function for geometrical purposes. So it has a vast applications in the field of geography and even defense and so many places. So let us have the Fermat's theorem. Okay, so what is the statement of Fermat's theorem? If f has a local extremum, extremums, it may be a maxima or it may be a minima. Local in the sense it is in the some interval from suppose a to b or some c to d or 1 to 2 or 0 to 1. So in that local interval, if you have maxima or minima, okay, then that is called a local extremum. Okay, I will give you example. Okay, let me draw a figure. Suppose that you have x-axis and y-axis, and suppose that the function you have with you is like this. So suppose that this is the function. So I can say that in this interval, in this interval, in this interval, this function has this as a minima and that has a maxima. So that is a local maxima and local minima. This function is in this interval from this second green line to third green line, it is having a minima and maxima is this geometrical. This is the maxima and this is the minima. So it is called local maxima and local minima. Okay, so likewise I can have n number of intervals here, so we will be recognizing what is local maxima and local minima. But if I talk about, so this you will be having what, a maxima, local maxima and local minima is somewhere here. Okay, if I talk about this interval starting with fourth green line to fifth green line, yes, you will be having this as a local minima and this will be a local maxima. But if I talk about what is the absolute maximum and absolute minima, so you will find that the deepest point is this point geometrically. Okay, so it is the point number 1. Okay, and the maximum point is point number 2. So this will be a local, this will be a global, or even you can say it is absolute minima, and this is global, or it is also called the absolute maxima of this function. Okay, so that is the application of the maximum and minima concept and the concept of local extremum. So you understood what is local extremum and even what is the global or absolute extremum of the function. Okay, so let me clear out this. Now what is the Fermat's theorem is saying? If f has a local extremum, so if f has some local extrema, that is some maximas and some minimas at c, and if f is differentiable at c, then definitely that f dash of c should be equal to 0. Okay, so if you look at this, if you look at the extremas, local extremas, so this is local extrema. Okay, let me go for the numbering. So point number 1, point number 2, point number 1, point number 2, point number 3, point number 4, point number 5, 6. Okay, so all these points you will observe that at this point what f dash of c is 0. What is geometrical interpretation of f dash of c is equal to 0? The geometrical meaning or geometrical interpretation of f dash of c is equal to 0 is that what at that point, yes, you have slope of tangent is equal to 0. I think in the previous section, in the first lecture, we have seen the meaning of what is f dash. F dash means differentiation, and differentiation means it is change in f with respect to change in x. Okay, so horizontal change to the vertical change, that is the ratio, and that ratio is called differentiation of a function f. And geometrically, we have proved that that is nothing but the slope, general slope of the tangent. And if slope is 0, what is meaning of slope is 0? You know that x-axis is having slope equal to 0. So if what any line is having slope equal to 0, then that line will be parallel to which axis? X axis. So you will find that yes, you will be having tangent at those point number 1, 2, 3, which are local extremas, maxima or minimas. So at that point you will be having tangents, and all that tangents will be parallel to which axis? X axis. You can see, so at this point you will be having a tangent like this. So if you have tangent like this, that tangents will be having slope equal to 0, and if slope is 0, tangents are perpendicular to, or sorry, tangents are parallel to x axis. Okay, so I hope that what you got the meaning of the Fermat's theorem. So what is Fermat's theorem? Simply saying, if you have local extremas at the point C, some point C may be 1, 2, 3, 4, 5 and so on, or it may be 1.5, 2.5, 3.5, something so on. So in that case, what if f dash of C, if f has local extremas, then definitely at those extremas at the point C's, you will find that the value of f dash of C is equal to 0. Okay, that is simply meaning of Fermat's theorem. So let me clear it out, and let us go for the next figure. Now here I have shown x axis, y axis, and there is a point C, and at this point C, yes, we are observing that curve is there. So at this point C, our slope, that is f dash of C, is equal to 0, and even your tangent is parallel to which axis? X axis. This line is a cusp. Okay, so at this line, actually f dash of C is undefined, and this function f dash of C is having value equal to infinity, and that's why it is parallel to which axis? Y axis. Okay, f dash of C is here undefined. Similar way, f dash of C is undefined here because it is not a curvature at the point C. There is a edge here, and that's why. And you can see this also, f dash of C is equal to 0. At this point, you have a line like this, which is parallel to x axis, but you will not find any local extremum at C. Okay, so here also f dash of C is undefined. Okay, it may be equal to infinity even. Now what is the criteria for recognizing the extreme points, and also what is the extrema, that is the value of maximum function and minimum function? So for finding that, let us follow this algorithm. Okay, so there are few steps. Let us read out these steps. So extrema or closed interval, suppose that what you have entered from A to B. If you want to find the extrema, that is maxima, minima, or both, okay, in the interval AB of a closed interval AB, means A and B are included, then following are the steps. The first step is evaluate f, that is you find out value of f at A and value of f at B. So find out values of function f at the endpoints. That is the first task you are supposed to do. That is your first step. Then find all critical points of that line over the interval AB. So find all critical points of f that lie over the interval AB and evaluate f at those critical points. Okay, critical point means you will be finding a value of f dash of x and equate that to 0. So after solving that equation, whatever the values you will be getting, then that values are called critical values or critical points. So critical points are the points at which there is a possibility of getting maxima and minima. So find all critical points of f that lie over the interval AB and evaluate f at all those points. So suppose that after solving solving f dash of x equal to 0, so you find you have f of x, find f dash of x and equate it to 0 and solve that equation for x. And suppose that you got x values equal to a1, a2, a3, then find f of a1, a2, a3. Okay, and then compare all the values of 1 whichever we got here from the node. The absolute extrema must occur at the endpoints or critical points. Therefore the largest value of these is absolute maxima, and the minimum value obviously will be absolute minima. See what is meaning of this? So let me show it with the help of graph. Let me draw a graph. So for drawing a graph, okay, let me have again x axis and y axis. So suppose that this is your x-axis, x-axis, y-axis. So suppose that there is a function f like this. So again, let me have a function like this. Let me have a smooth curve so that suppose that your function is like this. If you have function like this, then suppose that the starting point is here, starting point is here, x is equal to a, and end point is here, x is equal to b. Okay, so if you want to find the extrema between a and b, then first of all find out f of a and f of b. That is first step. Second step is, yes, you find out the critical points. So these are the critical points. What are the critical points at which you have f dash of c is equal to 0? So here you will be finding f dash of c is 0, here f dash of c is 0, here f dash of c is 0. So all these are the point at which you have f dash of c is equal to 0, and that points a, b, c are called, or that points a1, a2, a3 are called. So let us say that it is a1, this is a1, a2, a3, and so on. So here we are showing that what we got 3 values. It may happen you get more than 3 values, or even it may happen that there may be a single value or there will not be any value. Okay, so suppose if you want to find these a1, a2, a3 which are called critical points, simply you find out f dash of x, okay, and equate that to 0. Okay, so that will be an equation, that will be an algebraic equation. So if you solve that algebraic equation, you get values of x, and that values of x we are going to denote it by a1, a2, a3, a4, and so on. Okay, so these are called the which points? Critical points. Okay, critical points are obtained by finding differentiation of f with respect to x and equating to 0. So solving that equation we get x1, x2, x3, and that are called, or a1, a2, a3, that are called critical points. And then you find f of that critical point. So find out f of a1, not f dash of a1, find out f of a1, find out f of a2, find out f of a3, and already you have f of a and f of b. So see, yes, in the list of values of f of a, a1, a2, a3, and so on up to f of b, yes, whichever is the maximum value, that will be your absolute extrema or absolute maxima, and whichever is the least value, which is will be called the absolute minima. So let us apply this method to one function, with simple function, so that what you can understood. So here let me have a function f of x equal to minus x square plus 3x minus 2 over the interval 1, 3. So my first step will be, I am going to find out f of 1. So you will find that the value of f of 1 will be equal to 0. So if you put x equal to 1, yes, you get minus 3 plus 3 is 0. And the value, if you put x equal to 3 here, you get minus 9, and plus 9 will get cancelled, and you get minus 2. So first step is over. We got f of 1 and we got f of 3. F of 1 is 0 and f of 3 is minus 2. Okay, so we got 2 points. Okay, and the value of those points, the function's value at those points. Okay, now what is second step? The second step is, let us find out differentiation of it. We know that differentiation of minus x square is minus 2x and plus 3, and if we equate this to 0, yes, we get the value of x equal to plus 3 by 2. Okay, so we get value of x is equal to plus 3 by 2. So x equal to plus 3 by 2 is the only critical point. Along with this x equal to 3 by 2 critical point, you have 2 more points, 3 and 1. So in total we have 3 points which we may call it as probable extremum points. So these 3, or any 1 or any 2, or what, all the 3 may be extremum points. That is, few may be maximum, few may be minimum. Okay, so how to recognize which one is maximum and which one is minimum? Yes, you make a table like this. Okay, so if you make a table like this, yes, we have x value. So x equal to 1 we have taken as it is the starting point, x equal to 3 is the end point, and 3 by 2 is the critical point. So let us find out f of 1, f of 1 is already 0, already we have calculated, f of 1 is 0, f of 3 is minus 2, and f of 3 by 2 is equal to 1 by 4. So from these table it is very much evident that what 1 by 4 will be maxima and minus 2 value will be minima. Okay, 0 is neither maxima nor minima. Okay, so what is the meaning of this? 1 by 3 is having extrema at which points? At 3 by 2 and 3. So 3 by 2 is the point of maxima and 3 is the point of minima.